Learners also need to practice one-to-one correspondence, which means that they should know the number sequence and apply it to individual counters or fingers. This is referred to as rational counting. Learners who understand the muchness of numbers will also begin to realize the relationship between sets of numbers. For example, 4 dots are more than 2 dots. Teachers can assist learners with rational counting by pointing to an object and moving the object as it is counted. This can be done on the carpet where learners can be allowed to count different numbers of counters individually. This can be replaced by dot cards once the learners have had enough experience. Let's watch this video to illustrate it.
Hey, it's Nate. Today, I get to help my niece and her friends make caramel apples. Yum. Oh, I've been counting on this all week. You know, I bet we could use making caramel apples to make sense of counting and get another problem solved. Hey, guys.
Hi!
I hope I didn't miss anything.
No, we were just starting. You can sit next to Alex.
Great. Okay, where do we start?
First, we need to count the number of apples we have.
I can do that. Whoops, they went all over. 1, 2, 3, 4,
We
5.
counted that one already.
Really? 4, 5, 6, 7, 8, 9, 10.
You're going too fast. You counted this one twice. No, slow down.
Slow down your counting and make sure each apple gets counted once and only once. Children often miss items or count some items more than once. Sometimes they double count the last item because they are counting too fast to keep track of each item.
Why don't you try moving the apples into rows? That might help.
Like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Or make 2 rows of 5 like this, so it's easier to see the 10 and the 2 extras. So, how many apples are there?
Well, there are 1, 2, 3, 4, 5.
No, you just counted them. The last number is the total number. You don't have to recount each time.
12?
Right!
Some children don't understand that the last number they say when counting is the total number of objects. So, when do we get to eat?
Not yet. We have to follow the recipe on the bag. Go for 10 apples and we have 12.
So, do we have enough?
We do have enough. Ew, but these apples are bruised. So we're not using 2?
No, we are using 2. See? Not 3 and 5.
2 apples, not the second apple. We need to remove the third and the 5th apple. So we are removing 2 apples.
Oh. Children sometimes confuse when a number tells how many and when a number tells order. This is not 3 apples. It is the third apple. This is 3 apples. Or this is 3 apples.
We can just replace the 2 bruised apples with these 2 apples.
Do we need to recount?
No, there's still 10.
Children need to understand that replacing objects does not change the number of objects.
So the apples are ready. Now for the sticks. The package says we have 10 sticks.
Here they are, but it doesn't look like we have enough. We only have a few sticks in all these apples.
Are you sure?
Now we have more sticks than apples. I thought you said we only had 10 sticks.
Come on, Nate.
Children may think that spreading out the objects means there are more. Rearranging objects does not change the number of objects.
Let's put each stick in an apple to find out if we have 10.
There. Now we need to count the sticks. 1, 2, 3, 4.
No, you don't need to count the sticks. We know there are 10 apples, and there is 1 stick for each apple. There are 10 sticks.
If 2 sets match, they have the same number of objects. We do have 10 apples and 10 sticks. Nice. Now for the fun part.
Problem solved.
I love caramel apples almost as much as I love math.
Yum!
Object counting implies the process of matching a number in an ordered sequence with a collection of objects in a set. For example, counters, fingers, pictures, or children, with the aim of finding out how many. The last number assigned in the code is the cardinal number. The last number assigned is the cardinal number. How many objects of the set? Object counting includes correspondence and cardinality. Clemens and Sarama point out that a fully developed object counting scheme includes the following 4 components. Firstly, a situation. For example, a collection of countable objects, and in our case it was buttons. Secondly, a goal. To find out how many. Thirdly, the act of counting. 1, 2, 3, 4, 5. And fourthly, a result, the unitary whole of the counted objects. Counting with understanding means that a child can accurately count the number of objects, say 5, and answer the how many question by giving the last number name called. This implies that the child is beginning to grasp the abstract concept that the final number counted in a set represents the quantity or cardinality of a small set. For example, after counting a set and being asked how many there are in the set, they do not feel the need to recount. They know that the final number recited represents the total quantity. Learning to count is a complex process, and the development of counting is guided by a learner's understanding of a range of principles.